Okay, so today we'll start off. We're going to switch from angles over to circles. And believe it or not, there's actually a very close link between angles and circles. So we're going to review some things we did last semester, the parts of a circle. Pretend that's a circle. And one of the parts of a circle is the center. That's one of the things, one of the distinguishing characteristics of a circle. You can define it by its center as one of its things. Now there's one other piece that you need to define a circle completely. You need its center and its radius, which is just the distance from the center to the surface of the circle. Of course, that is the same in every direction if I had drawn that circle correctly. Another feature of a circle is a line segment with its endpoints on the circle. That is called a chord. And a chord that contains the center of the circle is called a diameter. Which brings us to our first mathematical relationship. D, which is the diameter, equals 2 times the radius, 2r. Next, we have the distance around the circle, which is called the circumference. We can have a line or line segment that touches the edge of the circle like that, but doesn't enter the circle. It just touches the edge. And if I'd drawn this perfectly, it would touch in just a single point. That is called a tangent. Tangent means to touch. And a longer line that contains a chord like this, it cuts through the circle, is called a secant. Well, that one's going to come up a lot. So now another relationship, we have diameter equals 2 times the radius. We have circumference is equal to pi times diameter, or circumference is equal to 2 times pi times the radius. So back to our circle. We have different angles that can be defined on our circle. One angle has its vertex at the center of the circle. That is called a central angle. It defines a sector. It also defines an arc. Now the length of that arc is defined by the angle and the radius of the circle. But oftentimes what we do is, let's say that this angle here is 28 degrees. We call this a 28-degree arc. So we can define it independent of the radius. Then once we know the radius, we can actually find the physical length of that arc. But 28 degrees means it takes 28 3/60ths of the whole circle. Little notation, by the way, often we'll refer to the angle as theta. Looks like that. It's the Greek letter theta. When we're defining variables for angles, we'll use A, B, and C, but we'll often also use the Greek letters alpha, beta, theta, gamma. Theta is the most common one used, but you'll see others. Phi. Phi looks like this. Alpha, beta, gamma. Phi generally looks more like that. Greek. They just to separate out angles from lengths. They use English letters for lengths and Greek letters for angles. Well, math is its own language, so just we'll start pulling in some other foreign languages too, right? So now, another thing that can happen is you can actually take a chord that connects the two endpoints of this angle, and that defines this piece here, which is called a segment. We looked a little bit last semester at finding the area of a segment. We're going to look a lot more at it this semester. Using our trig now, we don't need as much information. We can figure out a lot of the information ourselves. Another angle that can be defined is an angle with its vertex on the circle, and that's called an inscribed angle. It's inscribed because its vertex is on the circle. An inscribed polygon has all its vertices on the circle. This inscribed angle, by the way, will be half of the central angle that defines the same arc. So we'll look at that relationship a little bit more. Then there's something called an interior angle that just looks like this. Its vertex is somewhere inside the circle, but it's not at the center of the circle. That interior angle cannot be defined by a single arc. We might have two chords like this. If we know both of those arcs, then we can define the interior angles. And we'll look at how we do that as well. For now, see how much you remember. If I give you a circle with a radius of 4 centimeters, find its circumference. And we didn't go over the formula, but I'm hoping you can remember, find its area as well. You can look in your old notes if you want to. Yep, you can look in the book if you want to. So what'd you find for circumference? Okay, so it's pi times 8, right? So yeah, 25.13, we'll call it, centimeters. Area, pi times not 8, but 4 squared, which is going to be, what, 50.26 centimeters squared. Any questions? Hopefully that's all coming back to you, right? But also, as we keep going, let's say this is a 70-degree angle. And let's say I have another angle here that's 70 degrees. What can I say about that arc and this arc? They're the same length. Yes. Well, first of all, they're both 70 degrees. And then their actual length is defined by their angle and their radius. And since they're in the same circle, these radii, all 4 of these radii have to be the same. Or even if I had another circle that we knew had the same radius, and this was 70 degrees, these arcs have to be the same. So anytime you have the same radius and the same central angle, the arcs will be equal. The arc lengths will be equal. Similar to that, what if I draw this chord in and this chord in? How are they going to be related? The chords will be the same length. So if you have equal arcs, the chords that connect their endpoints will be the same. Or the other way around, if you have equal length chords, they cut the same arcs if they're in the same circle or circles with the same radius. If I tell you that this is a 76-degree arc, what do I know about that angle? 76 degrees. What do I know about that angle? Half of 76, 38 degrees. What do I know about that angle? Also, it's still an inscribed angle, it's just way off to the side. It's still 38 degrees. How about this one? 38 degrees, yes. Any inscribed angle that has its endpoints on that arc is going to be 38 degrees. What's that? For now, what do we know about that angle? No. It's smaller than 76, but it must be larger than 38. Does that make sense? It's between the two. The question is how much smaller than 76 or how much larger than 38. That depends on this arc here, and we're going to learn that rule later on. How's about this angle out here? Less than 38 because it's further away. It's got to be narrower. Very good. We've already used this rule a little bit, but we should define it. Let's say I have a radius here and a tangent that's tangent to the circle. They make perpendicular. Yeah, the radius to that point of tangency is perpendicular to the tangent line. We've already used that in some of our ball problems and our rod and groove problems, thread problems. But it is a very important piece of information for us. Another important piece of information, let's say I have a chord out here and I draw a radius. Now I can do this one of two ways. I'm going to start out by saying this radius makes a right angle with the chord. It's perpendicular to the chord. But what do we know? What do we know about this length compared to this length? They're equal. They're both radii of the circle. What do I know about this length compared to itself? It's the same, right? So I have two sides, and I have a right angle, which means I know the third side, because a squared plus b squared equals c squared. So what I have is I have two triangles that must have all three sides the same, so they're equal. So what does that tell me about this length compared to this length? It's equal. So that radius, if that radius intersects a chord at a right angle, it cuts it in half. Now it also goes the other way. If that radius intersects the chord and cuts it in half, then it must form a right angle. There are a lot of things we're going to do where we need to have that information, where we can assume if we cut that in half, it's going to make a right angle, or if we draw it in at a right angle, it's going to cut it in half. Having that information allows us to do a lot of things with our circles, especially when we're doing with measuring distance between 2 points on a circle. Let's see, what else do we want to do here? Oh, yeah, that was important. We ran into this one a little bit as well. So we've got a ball that's hitting in a groove here. 2 points of tangency. Of course, we know that the radii make a right angle with the tangent. But let's look at the distance from that point of tangency to the point down here on both sides. That is also going to be equal. Because if I cut this across here, of course, this is equal to that because they're both radii. It is a kite, you're right. These are both right angles. And of course, this side is equal to itself. So you have two sides and an angle in a right triangle. And in a right triangle, if you have two sides are equal, the third side must be equal. Because of a squared plus b squared equals c squared. Well, let's keep going. There's a whole bunch of these rules we can throw out here. So as I said, if I define this to be a 51 degree, well, let's make it 52 degrees, a 52 degree arc. What's this angle here? 26. What's this angle here? 52. Because the central angle is equal to the arc and the inscribed angle is half the arc. So what if we do this? We said we know this angle has to be smaller than 52 but bigger than 26. What determines how much smaller than the 52 or how much bigger than the 26 is where it's located between there and the outer edge of the circle. And the way we measure that is by using the length of this other arc. Let's say that this arc here is 24 degrees. This angle in here is going to be the average of the two arcs. 52 plus 24 divided by 2. So that's what, 76. Comes out to be 38 degrees. We've said that this angle has to be smaller than the central angle and smaller than the inscribed angle. So if this here was 48 degrees, again, we know this has to be smaller than 24 because the inscribed angle here would be 24. How much smaller? Well, it depends. The bigger this is, the smaller that angle is because the further it has to be away from the circle. So let's say that this here is 18 degrees. This angle is found not by adding the two arcs, but subtracting the two arcs and then dividing by 2. So 48 minus 18 is 30 divided by 2. That makes that a 15-degree angle. Make sense? Well, then let's take a look at some things here. So if I give it that angle is 31 degrees, this arc is 38 degrees. This arc in here is 16 degrees. I want you to find this arc and that angle. And this angle. Okay, so the first one that we can probably find is this one over here. What's that going to be? 31, or not 31, 38 minus 16 divided by 2. So that's 22 over 2 or 11. So 11 degrees. How many had 11 degrees for that? Did you see what you did? I started out with 31. Now, of course, to find this one, we know that this whole arc has to be 62. How do we know that? Double the 31. So that means that this piece has to be 62 minus 16 is 46 degrees, correct? So then this angle, 46 plus 38 divided by 2, which is 42 degrees. Anybody have all three right? Well, let's try another one.
Can you go back up there?
Sure.
Why isn't the opposite chord, the opposite arc, 38 degrees?
Why isn't this one 38 degrees here?
It has two intersecting lines that are the opposite.
Yeah, but this isn't at the, if that were at the center, it would have to be 38.
Oh, I thought it was the center.
Nope, it's not. Good point, though. Yeah, if that were at the center, they would have to be the same, but it's not. Okay. Okay, what's going on? My mouse is not working.
Confused. Roll it.
My mouse decided not to work. I'll have to reboot it when we're done with lecture here. Don't fear, we can get through lecture without the mouse.
Oh.
Pretty much, yeah. You sidewalk chalk? Oh yeah. Oh, there's tons of chalk dust in there. Okay, so in this one, this is the center. So this is the center of the circle. Find this arc and that arc. What did you find for this one? this one here is going to be 44, right? Which makes this angle here 44, right? Which makes this angle here 44, which makes this arc here 44. So that makes this arc 44 plus 18, or 62, which makes this angle 62. Of course, that makes this 18. And since this is the diameter of a circle, this arc has to be 180. So 180 minus 62 makes this 118. Anybody have those right? Might take some practice, you're saying? Well, I think it's maybe time we start some practice. Let me grab a packet here. More dead trees, I know. Let's see, two more.
Yesterday about it. I think you got to get a little more crowd. You better.
Well, the difference is you see his pants, there's all the parts on there.
He doesn't pay for nothing.
He doesn't?
No.
His paint all
Pay
there.
for it.
Richard is that.
Okay, so in these packets, page 305 through 306, 1 through 26, and page 315, 1 through 26, the odds. So 305 to 306, and then 315. This one go up to 315, or do I need a second packet?
305 only has 4 questions.
It goes on to 306.
6 of 11.
Yeah.